Hello, I hope everyone's doing fine. So today I will be recording another video of like one of the questions that I found interesting on Leetcode. It is based on stacks. And since stacks again is you might get a coding problem in stacks in your midterm or maybe in your FE. So I decided, hey, that I should make a video on this, and I just find this question fun. So yeah. So the name of the question is valid parentheses. I also was able to cover this question in one of my labs. That is also another reason that I'm recording it. I thought it would be unfair for the rest of the students who didn't attend my lab. So that's also one of the reasons. I just wanted to showcase you me solving this problem because I had like extra time left in my lab, so I was able to go through the problem conceptually. So yeah, so the name of the problem is valid parentheses. It's on Leetcode, and the gist of the problem essentially is you're given a string which represents a set of parentheses, right? Your task at hand is to determine if the said string is balanced or not. So a string is balanced if the opening parentheses matches the closing parentheses, right? So another way of thinking about it is, wait, hold on, is the nearest closing one, the nearest closing parentheses matches the nearest opening parentheses. So this does match, so that is fine. Again, now I'm at position this and this. These do match, I'm fine. These also match, I'm fine. So this is balanced. Again, you can have a string which is like a nested sort of parentheses. Again, we'll apply the same logic. We check if the nearest, so first I encounter a opening parentheses, the next again I encountered an opening parentheses, now I encounter a closing parentheses. In this scenario, I need to check if the closing parentheses matches the nearest opening one. It does match, I just get rid of it. Again, opening, opening, closing, these two again match, get rid of it. Now I'm at here, this matches with this one and I get rid of it. This matches with this one and I get rid of it. Again, this is balanced. One scenario that might occur that the first parentheses that you encounter is a closing one. So the order in which these parentheses occur, they matter. So in this scenario, order matters, right? Since the very first parentheses I encounter is a closing one, I automatically know for a fact that, hey, this is not a balanced parentheses, right? Again, in this scenario, we'll just kind of do a dry run. I encounter an opening parentheses, that is fine. Again, I encounter an opening parentheses, that is fine. Now I encounter a closing parentheses. These two, they do not match. The nearest closing one does not match with the nearest opening one. So I know for a fact, again, that this is not a balanced set of parentheses. So that's like the whole idea of this, of how do we tackle this problem conceptually. We'll come to the coding part later on, but that's how you essentially determine, just by looking at it, uh, if a given set of parentheses is balanced or not. Now, what we need to do is we need to write the code for it, right? So what we'll do is we'll use a stack data structure, and it will make sense when I'll do the dry run. So we'll use something like a stack over here, and I'll take one of the examples from, let's say I'll take an example like this, the first example. What we need to do is obviously have something like stack. This is how we like represent our stack visually, right? A stack again is what? A last in, first out data structure. So you also might need to remember this. Again, a couple of rules we need to keep in mind is, first, we only add open parentheses, open parentheses, okay, my God, open parentheses to our stack. So that's the first rule that we need to keep in mind. We only append the the opening parentheses on my stack. The second thing I need to keep in mind is, if I see, or if I am at a closing one, closing parentheses, I need to keep check of two things, right? First, I need to check if the stack is empty or not. I need to see if stack is empty. Because if the stack is empty, that means automatically that the given set of parentheses is not balanced, right? So let's say we had something like this. Like this was our string, right? If I'm here, I if I'm here, this is a closing parenthesis, right? So the rule is I only append the opening parentheses, and at any point I encounter a closing one, I see my last value in my stack. Again, this stack is empty, so I know for a fact that this is a non-valid set of parentheses, right? So that's the first step. I need to see if the stack is empty or not. If it is empty, automatically false. Second thing I need to check is uh, if the stack is not empty, if not empty, check if the closing parentheses, the closing parentheses matches or maps onto the opening one. Maps onto, oh my god, sorry about that. Oh my god, I revealed my okay. I revealed my my thumbnail, sorry. Okay, so check if the closing parentheses maps onto the opening one. Opening one. So that's essentially the plain English of what my code should look like. So that's the whole idea. Now let's do a dry run of the code, and I'll draw my stack again here. And let's pick one example like let's pick this one since like it's easy for me to showcase. So let's choose green, and we have this, we have this, we have this, we have this, and then we have this. So again, my first rule is I only append the opening parentheses, right? So I'm here, this is an opening parentheses. I just added to my stack, right? Now I'm at a closing parentheses. First thing I need to check is the stack is empty. The stack is not empty. Does this one map onto this one? It does, right? So I just get rid of it. Again, now I'm here. Now add it to my stack. Now I'm at a closing parentheses. Now I need to check two things. Is the stack empty? The stack is not empty. Does this map onto this? It does. So get rid of it. Again, opening parentheses, add it to my stack. Now I'm at a closing parentheses. Check two things. Is the stack empty? Stack is not empty. Does this map onto this? Yes, it does. So we just get rid of it. And at the end of the string, we need to check by the time I reach the end of my string, I need to check if my stack is empty. If stack is empty, if not stack, right? If not stack, that means we're good to go, that the set of string was balanced. But if stack, like if the stack is not empty, that means that the given string was indeed not a balanced one. So that's like the whole idea of like a high level concept of how to approach this problem. So I'll just get to the coding part of it, and yeah. Here's the problem. As you can see, valid parentheses. It's an easy problem, but I would say it's definitely not the easiest problem, if you will, because the thing is, if you're solving it in C, you kind of have to manually keep track of your stack, right? You kind of have to decrement and increment your top tracker manually. But again, it's easy if you clearly understand how the top tracker works in the stack and how when we pre-increment, when we post-increment, those kind of things. It should be pretty straightforward. But with that being said, I'm just gonna go solve this code. So first of all, I'm just gonna get the length of the string, right? So I'll use string length of s. So n is now the length of the string. Now I will declare my stack, which is a character stack, so char stack, which would be the same size as my string. Then I will have my top tracker. As you know, top tracker always starts at -1. So this in these three lines, I've declared my stack essentially, right? Now I need to loop through my string, right? So for int I equal to 0, I is smaller than, again, you can use string length or you can use n, but I'm using n because I want to be like uh, I want to improve on my time complexity, I plus plus, because string length function also takes O of n time, so keep that in mind. Now again, we discussed two steps, right? So step one, only append opening parentheses. Okay, I cannot type parentheses. Step two, if a closing parentheses is seen, check if not stack, check if not stack, and check if it maps onto the last parentheses appended. So this is what we load. So if I'll just check if I'm at a opening parenthesis first, right? So if s at I equals to a opening parentheses, or s at I, sorry, s at I equals to again this opening parentheses, or s at I equals to a this opening parentheses, I'll just add it to my stack, right? So now remember, we in a stack we pre-increment first, right? We pre-increment and then we add the value. So pre-increment top tracker. I cannot type that. I don't know what's going on. So top plus plus and then stack at top catches the value of s at I, right? So that's the whole idea. Now the opposite of that would be I really cannot type that. Okay, so the opposite of that would be I'm at a closing parentheses, right? So again, if I'm at a closing parentheses, I need to check the first thing first. If top equals to -1. What does this mean? This entails essentially that the stack is currently empty. So I can just say, we can just return false immediately back to the function if the stack is empty. If that's not the case, I need to pop the last value, right? So char, let's say last val equals to stack at top and then decrement my top by 1. Okay, now since the stack is not empty and I have the last value that I added to my stack, I need to check if it maps onto the opening parentheses, right? So if we can just say if I'll just you do this, if s at I equals to the closing one, so if s at I equals to the closing parentheses and last val does not equals to this one, right? Or again, s at I equal to this closing parentheses and last val does not equals to the opening of this, or again s at I equal to this closing parentheses and last val that was popped from my stack does not equals to uh, this opening parentheses. I know for a fact that hey, that this is a wrong subsequence, right? So I can just say, I can just do this, return false immediately back to the function. So hopefully that makes sense. So if the last value I encounter was a closing one, I pop the value and I check if they map or not. So that's the whole idea, return false, right? At the end, I just need to ensure that return top equals to -1. So this is, I'm using the ternary operator here. So that's the whole idea. So now let's try running the code and see if it works or not. So, okay, there's an issue. Oh, last well. Okay, let's see if it runs now. As you can see, it runs perfectly fine, and I'm going to submit it. Hopefully, goes everything smooth. And yeah, that's essentially the whole code. You guys can take a picture of it or try maybe solving it on your own, but that's like the whole code.